Okay.
Yeah, Praveen, yes.
Okay. You guys all know this, right? Okay. And when it goes to specific route decision, how this route table works, if you have a same route, for that, I think we have to enable some routing here. So that's something when we do OSPF now, we will learn this together. How this route decision differs if you have the same route for the specific destination, but you have two different routes coming from two different routing protocols and how this route is going to decide. And there is some kind of troubleshooting when you're actually, if you see, I have seen this in my scenarios when I work with routing. If I go to R3, where we had a problem is we had a proper route to the next stop, but the packet is not actually properly routed. That's something they did something configuration, a different configuration on the SD-WAN, but from the Cisco standpoint, if you can use this command, if you are aware of it, I don't know, ipsef command. This is similar to your Juniper and FortiGate. They say forwarding engine. So there's two routing tables, right? I mean, three tables. I think one is. Let me take this pen. You got your global routing. That is your route table. IP route in Cisco, I think show route in other vendor. So you will have only the best route here. One more is a forwarding table. Example, we are running OSPF. So OSPF maintains its own route table, right? Say for example, I have reachability to 10 subnet/8 from OSPF, and I have a static route for the same with static route. So which route is going to be, pushed to my route table, IP route table? So whatever the the network you learned from the static, or maybe whatever the routes you see on your route table, that's again pushed back to your forwarding table. Sometimes what happens, even if you see the route in your route table and if it is not actually forwarded, you should check your forwarding engine. Is it properly forwarded back to the next route properly? So if I give this, um, say for example here, show running section route. So you got two routes. I mean, so you got two default routes, two different next hop. But based on this administrative distance, in your route table, you are going to see one route, one active route, 10005, because this is hard down. If you see, so show IP safe, it's a forwarding table. I think it's show IP forwarding, no, show IP. What is that? This command is safe. If you give this, so it is telling that, see, my next stop here is 10005 now, because that is active and it's going to show me which interface it's going out. Even the route table, you see that. So you can see all your attached networks. So this is the 10 network, right? If you see this show IP interface brief, see you have your 10 network on R3. So all these attached interfaces, whatever you're looking at here, they are all directly connected. So even the routing table, you guys know about this. The most preferred is directly connected. So this is most preferred. Then comes your static route. Then comes your default route. Then your dynamic routing. This is all purely based on the administrative distance. By default, I think it is one for static and default, and OSPF something lesser than EHRP 80. I have to check. I don't remember. Something the value is between 80 to 100 for OSPF. So the least administrative distance is preferred. That's one thing. The most highest prefix is more preferred. Example here, if I am doing this, show running section route, I'm on R3, I'm going to R1. Show run section route. So I have for this 10 network, my prefix is /24. So what if I say show IP interface brief? So I got two network, right? So one is 40, one is 20. So I'm going to change this to IP route, same network 10.0.0.0, but I'm going to give a prefix length 255.255.254. So my next stop would be, I'm telling my next stop would be 20.0.0.5 for the 10 network. Oh, sorry, it's 20 is here. So I am on R1, so 20.0.0.1. Let me give 20.0.0.1. It's my local IP, so it is not allowed. Route. If I give show IP route now, so this is more preferred than 40.0.0.1 because the highest prefix length is preferred for it. So if I do a trace route for one minute, I think it's not working now. So if I do show IP route for 10.0.0.0, so I was telling 40 and 31. If I do a trace route, not working now. Let me close this. So if I do a trace route 10.0.0.1, where's my 20? Is it 20 is up? Show IP interface brief. So I'm on R2 going to GI0/0. Interface GI0/0. My IP would be 20.0.0.1. So we did a trace route from R1. Show IP interface brief. Ping 20005. So it says unreachable, yeah? Because we didn't turn on the link. We do so I'm coming to 20 and I should see 10. My 10 is on, not 2. So it is going out of 20001 here because it got the highest prefix length here. Even though I have route for the same destination, but with different next hops. So the next hop is preferred based on the highest prefix length. This is 32 and this is 24. So do you guys all know about this? Feel repetitive, this one? Okay. So now let's go to this, how the routing logic, if you look at this, the content, this is a route logic and selection of route happens like this, and static route with the longest prefix is preferred. So now let's go to the OSPF. I have seen people asking you, even I stumble upon when they ask these questions. But if you do this lab, definitely I would tell you this helps a lot for to crack your interviews. Even for now, you may go to SD-WAN, you do your Meraki, you do your Viptela, you do your Juniper, any vendor specific. But the in the classic devices, if you learn the packets, believe me, it would be really helpful to troubleshoot your problem. So the classic devices, it gives more CLI and you can use Wireshark, right? So I have seen in my experience now the Meraki has completely they changed and they don't have a CLI. They are using just a Wireshark to do everything. It can be your ARP issue, it can be your routing issue, it can be your GRE, everything. You should understand the packets. And we all know this. You don't skip layer 3 is just it's a routing. I have seen people doing that, but your routing is the base foundation for everything, even if you're doing your security. So give importance to OSPF and learn OSPF. So when it comes to OSPF, this is very beast protocol, right? It is not like other protocols because you have different area types, you have different LSAs. So people generally they ask questions like in OSPF, what are the LSA types? Uh, LSA type 1, type 2, type 3, type 4, type 5, and type 7. So totally we got 7 LSA types. I think you guys all aware of it. So that is type 1, type 2, type 3, type 4, type 5, and type 7. And there are some opaque LSAs. That's something we don't want to focus much. Even people, they don't ask much about that, but they will focus only on these 1, 2, 3, 4, 5, 6 LSA types. Say, for example, you got something routers like this, right? And you make this as a area, different area. This becomes an area 0, and this becomes an area 1. So all this connected interface, whatever the connected interface I have, including your loopbacks, so all your connected networks, this particular LSA type 1, that is flooded only within the same area. That is the first thing. All your connected network within the same area is type 1 LSA. And all these routers, right? They maintain something called as link state database, LSDB. So inside your link state database, you would see your type 1, type 2, and type 3. So why it's so important? If somebody is advertising, when you are troubleshooting a problem with this, inside my type 1, I should see all my connected network as well as my neighbor connected networks. I should see that, and it should be exchanged on both sides. So this is primarily a type 1 LSC. So now let's go and configure it. Let's see. And also we'll do a Wireshark capture. For that, let's go to a different lab, because here I think the capture is on either end. We should at least have one Linux. Okay, let's take here. I mean, let's take this side and we'll do an OSPF, and let's try to do that. So we will discuss more about type 2, type 3 in the next class. So now we will focus only on type 1 LSA, and we'll do a lab for it. So in OSPF, generally it maintains three table: neighbor table, topology table, and routing table. And it runs on open shortest path first, and the whole thing is called link state database. So I don't think we need more theory about this. So this is something we know, this we discussed. This is the codes admin distance next stop. So we're going to the lab. We'll create a type 1 LSA and let's see what we see there. Let's use the same lab. Let me turn on a Linux on both ends. Now let's purposely remove few routes. So 4010, I think there is some duplicates in the IPs, right? So here we got 10 network, and here if we go, let's do some corrections here. This is, we got 10 network. I'm going to R1, show IP interface brief. This looks good. I got 40 and 20. There is no duplicate IPs. Then if I go to R2, something, we got again a 10 network here. Let it come up. So let's go to the switch. Okay. If I give show IP interface brief. So let me remove this network, because we got same network on both end. Interface VLAN. Then let's change this to not to, let's use 40. Let's use 50 here. Let's make this as 50002. I'm going to R2, going to the interface GA0/1. This is 50.0.0.2 and this is 50.0.0.1. So assign an IP address 50.0.0.1 255.255.255.0. Oh shit. This is not just we are bringing up the connection doing a routing, right? So we are going deep into the LSAs and we see what is being exchanged and received, and we'll do some troubleshooting there. R3 50.0.0.1. Interface GI0/0. That's something we have duplicate IP, so no IP address. IP address 50.0.0.1 255.255.255.0. Is it we used 50.0.0.1 there? Change this back. We make this 2. This interface is 1. We ping across to test the connection. Can ping it. I can see the ARP on both ends. Okay. So now let's configure the OSPF here. So for this, is there any? I don't know. Let me change this color. I don't know, it's just not visible, right? Okay, let's do this. This is area 0. This side. This side, let me configure area 1. And we'll create some loopbacks for testing. R3, I'm on R3. So we got a loopback 3. This guy's 333 is a loopback. Two dot two dot two. This guy is 2.2.2, right? Loopbacks on the top. Going to R2. Interface loopback 0. IP address 2222.255.255.255. Show IP interface brief. So now from R1, show IP route. I don't know about the loopback 2.2.2 that is on R2. Same way in R1, sorry, R3 and R2. So this is R3 and in R2 we got a loopback 2.2.2, right? So we made these two areas. Only the R2 and R3 is involved here. So I don't know about from R2. I don't know about 3.3.3, right? So now I'm going to configure the OSPF. Going to R3, show IP route. I don't know true network either. So I'm going to do IP router OSPF. Sorry, router OSPF. One, process ID. And it's a good habit to always to use router ID. So that's on identification. That's something we discuss about. I mean, we will discuss about the link state ID. So about both, it uses the reference as a router ID for link state ID. I'll show you in the topology, you'll understand. So the router ID is something I'm giving the loopback address here for identification where I'm receiving the routes from. It's like labeling the routes. So labeling the router. So I'm going to enable OSPF where on all the network, all the connected network. So all zeros. So it's on wildcard mask all zeros. And I'm going to say area 0. This side, right? R3 is area 0. So I'm going to R2. So I should see, so here I should generally see only the 50 network and 2 network. I should not see anything coming from this side, 40 or 20, because let me take this pen. So because only this area, whatever connected to this, I should learn this from type on LSA. So process ID, same process ID 1. So I'm going to enable OSPF on all the interfaces. So all these interfaces are something, so I'm cover the whole network with zeros, 0, 0, 0, 0, 0, 0, 0. And my area on R2, it is area 1. So what it says, there is an area mismatch because this is an ABR. This guy is an ABR, right? So let's see the same thing in the capture. I think we can see the capture here. We enabled OSPF. turned on. Let me close this Linux and open this Linux. Okay, so Ember captured and okay, didn't work. Okay. So going to the login, I'm in the Linux. So I'm going to capture the traffic on Ethernet 0. Do I see that coming back here for this network OSPF? I'm going to R3. Show IP interface brief. So this is connected to GI0/2, GI0/2. So I didn't assign anything here. Let's delete this too. Let's just rename this to 60. Interface GI0/2. Configure interface GI0/2. IP address 60001. 255.255.255.0. Oh shit. So coming back here, 600010. So we see some OSPF packets going out. So let's do manual. Let's 600010, 60001. Apply. Go to the capture. Do this from the beginning. Type only OSPF. Think can flood some more traffic here. We receive only from 60. R3. So now show IP OSPF database. So this is 3. I didn't even establish a neighborship. I didn't establish a neighborship from this guy R2, right? So I should give a command show IP OSPF neighbors. I don't see any neighborship there. Show run section OSPF. So this is my router ID. I'm telling that I'm going to enable OSPF on the whole network. Did I keep network all zeros? Wildcard mask all zeros. Area 0. Going to the other side, R3 and going to R2. So we are keep receiving the different because this is a area border router, right? So I'm going to be specific here because I'm using two different area types. So for this 50 network, which is facing this side, it has to be area 0 and this side should be area 1 because this is a backbone area connecting two different areas. So run section OSPF. So now I'm going to say instead of this, I'm very specific about my network. I'm telling network 50 on R2. So I'm going to say 50.0.0.0. 255/24. I'm telling this could be the area 0. This one, this part. So I see my neighborship is up now. So let's see the captures, what we see there. I don't think we can see all this link state database packets here. All I see is hello packets. Let's go to R3. If I do show IP, OSPF neighbors. So by default, it's all a broadcast. I mean, the connected interface, it will be in a broadcast network, right? Usually broadcast is used for LAN subnet. So that's coming. I mean, the future classes will discuss about. So by default, it's a broadcast. So my neighborship is up now. And if I go and say show IP OSPF database, this is now you see the LSAs. So the very first LSA, what you see here, right? This is your type 1 LSA. Here, router LSA is your type 1 LSA. This is your type 1 LSA. So all your connected network within the same area. So these two routers we have and all your connected networks you should see here. So how do I see that? Show IP OSPF database, then followed by, if you see advertised router, so all I'm receiving from, I am on R3, I'm receiving from R2. So R2 is router ID is 2.2.2. So I'm going to put 2.2.2. So you can see this advertised router is 2.2.2. Let's wait for some time, it didn't work. Let's go to the other side at least. R2 show IP OSPF database router. From here, I'm going to see what R3 is advertising. So we are receiving this from R3, right? I am on R2. So I know about 60 network, I know about 50 network, I know about 3 network, and I know about their subnet masks. So there are totally three links here, connected links. So this is router LSA. So if I'm going to R3, I'm going to verify that. Show IP interface brief. So I know about 50, I know about 60, and I know about 3 network. And you see this 100,002 is admin down. So I didn't receive it. So it is telling that all my connected networks comes as a type 1 LSA, and I see these three networks, connected network 50, 63. So I should see this on either side. I'm going to R2. So from R3, I'm telling I received three connected links. One is 3, 60, and 50. 3, 50, and 60. Right? So this is the primary LSA, type 1 LSA. That's something I thought we should see that here in an LSDB update. But since we don't have a direct capture here, we have to do it in a different RDP. Or else we have to connect a device in the middle to capture that, because only the type it goes as a link state database. So you can see the same result here, but here I see only the hello packets because this guy is not doing any OSPF. This is since OSPF enabled here, but your whole LSA updates has been exchanged between these two links, and I should receive that. So we should do the capture in the different RDP next time. And from there, all the OSPF classes will continue on that RDP. So this is your type 1 LSA. In type 1 LSA, I don't see anything apart from that. So type 1 LSA is just a connected networks. So any questions related to this, what we discussed so far? No questions from anyone? Okay. Apart from that, anybody has any questions about today's topic? I mean, related to DHCP and the OSPF? Everybody is good? Okay. So now let's discuss about the different type of OSPF networks. I mean, one is there are predominantly two. One is point to point, and another one is broadcast domain, and sorry, broadcast and non-broadcast point to point. So when we say point to point, say from here from my R3 to R2, it is just a point to point connection, right? It's a directly connected. Say for example, if I have a switch, something like this. Let's go to the whiteboard and show you that. Do we have anything for? I don't know how. I mean, I don't see the enterprise they are using it. I don't know. In my design, I never seen that. Maybe it exists, I think, but in OSPF, there's one more topic like the broadcast network. So in broadcast network, that is a bit different. So what we are looking at here is just connecting the routers like this. So by default, the network type is broadcast. You can see this even in if you do this show IP OSPF interface, I think. So this is all very important when you troubleshoot actually. See, this is, I'll tell you the importance of this. So network type is by default is a broadcast. You can see that here. So for this by default, that's fine. But if you are using a kind of a LAN segment design, I think it's a show IP OSPF interface brief, I think. Yeah. There is a command to see what type is this. State I can see. Show IP OSPF. What is that? It's not in top of my head now. That's something you can see the interface type is point to point or broadcast. Okay, that's fine. So here, if you see, this is a point. This is by default it is a broadcast. For general people, they do it as a point to point. You can change that either side. You can see that. So one end, if I configure something wrong, the neighborship gets broken. Going to R3. And I'm connected to R3 50002, right? I go to this. So the network type should match on both ends. GI0/0 IP OSPF network. If I do point to point, see, so received an hello, network type is mismatched. If I go to the other end, R2 GA0/1, show IP OSPF interface. If I give this interface 50001 GI0/1, I think it's not that command. So you can see the network type is a broadcast this side. If I say show IP OSPF neighbors, interface GI0/1 OSPF network. If I do a point to point here, so it's from full to down, now from it's loading to full. Show IP OSPF neighbors. So now it is up. If I check now, show IP OSPF interface GI0/0. So now network type it is telling that point to point. And it shows the adjacencies with 2.2.2. So both end has to match the same network type. You can't have one end as a broadcast and other end should be a point to point. By default, it is a broadcast. So when you see this kind of a deployment, usually they use point to point. But when you have something like a switch in the middle and you got multiple routers connected like this, I don't know, this kind of deployment is widely used, but here we call this as a broadcast. So, and only in the broadcast domains, you will see this DRBDR election, designated router and backup designated router. So this guy is going to send all your link state updates to the neighbors, right? Any questions on this OSPF network types and DHCP, whatever we discussed so far? No questions from anyone? You guys are good? Any other, questions or anything else, whatever it is you guys want to discuss?
I mean, can you attach Wireshark to the other end routers also, like when you do the next scenario or something? So I think this one in the capture, we will be able to see that network mismatch, uh, like
Yeah,
part
yeah, yeah,
and
yeah.
broadcast.
I'll do that. Yeah, I'll do that. Actually, I thought of doing that in a different RTP. I just continued with this DHCP after DHCP. I just continued with that. Yeah, definitely. I'll show you this LSTP updates. Exactly, I will show you where in the capture inside the OSPF you see that type 1 LSA, type 2, type 3, everything. Yeah.
Yeah, yeah, thanks.
So do you guys know about all this? This is something you guys feel this is something you guys know before,
Yeah, I worked on it, so I'm aware of it.
aware of all this? Okay,
Yes, yes.
fine. So we'll do also the MTU mismatch and see if the neighborship. So if the neighborship is not happening, there are two ways. One is mostly because of MTU, and the other thing is could be the network mismatch. And we will see about the passive interfaces and other parameters of OSPF in the next class with capture. And we'll do some troubleshooting with that. Fine, everybody. So do you guys are aware of how to take the capture of a DHCP and to explore more? Okay, then fine. We'll see in the next class.
Praveen, one
Yeah.
thing, like based on your experience, so what kind of network type in OSPF you have seen, like
Usually we do point to point.
point to point only?
Yeah, because I haven't seen a deployment with broadcast. By default, it is a broadcast, but we generally have this SD-WAN router connected to the core switch, and that one particular VLAN is always we make it as a point to it.
I have seen like point to multi-point, point to point, and I think broadcast as well. I have seen like
Oh, is it? Yeah.
yeah,
Yeah, but
you,
there is non-broadcast multi-access
uh,
broadcast domains. But it depends. I mean, how people feel. I mean, do you guys want that to be covered? But I think is it in the syllabus?
previously, like in hub and spoke scenarios, we usually like do, I think over the DMVPN, we use like point to multi-point,
Yeah,
non-broadcast.
yeah, correct. Yeah, in BMA we use that. Yeah, in the in NHRP, in the next what is it? In the what do you say for that? The main hub router.
Mm-hmm.
Yeah, we do that multi-point.
Point to multi-point, correct.
Yeah. So do you guys still use DMVPN?
Uh, Not recently, I have seen, but a year back, like I saw one of the client. He was
We-
using DMVPN.
yeah, yeah. But I have seen people in US they are using mostly the DMVPNs, right? Still they have it because it's a cheaper solution for them, I think.
I I told you, na, like even I have seen frame relay. So
Ah, yeah, yeah. Frame really is very difficult. Oh my God, still. And the what is that? Back in
yeah,
2000s, I
Delphi,
think CCAE, Dell C routing and
Delphi
switching
and
is
all.
very complicated with that, but now it becomes very easy with SD-WANs.
Yeah, so now things are moving forward, like even for the for this SDN as well. Like mostly it is not OSPF, it is ISIS is being used
Hmm.
for
And
the
for
underlay.
yeah, yeah, correct. You're right. Yeah, in SDN, I heard that they are using yeah ISIS for it.
ISIS and BGP.
Hmm. ISIS and BGP for is it ISIS for underlay, right?
Yeah, for the underlay, right.
Okay. But I mean, yeah, if you go with any vendor or device, the routing is the same story, but the way how we understand some troubleshooting, maybe that helps. I have seen that in some scenarios, if we are not receiving specific routes attached to it and we are not receiving it, that's something going inside LSA and check is something we didn't do it in the mid junior level, right?
Correct.
That's one thing you that feels different or happy when we do the lab. But apart from that, it is just network command configuring it. So no
Per-
joy in that.
Personally, like I have worked more on ISIS than OSPF.
Oh, is it?
Yeah.
ISIS is a bit difficult, isn't it?
Oh, it is quite simple. I mean, like
Quite
even
some.
it is simple than OSPF.
Oh, is it? Okay,
Yeah.
I think in OSPF they have different LSA types and area types.
In ISIS, we are having that CLNS neighborships.
Mm-hmm. And also in SDN they are using Lisp, yeah,
Lisp.
along with yeah.
Correct. Yeah, that is also similar to ISIS only.
Oh, is it similar to
Yeah.
ASIS? That is used for some endpoint discovery, isn't it? For Lisp that uses
Correct.
endpoint discovery
Correct.
and doing
Correct.
it.
Correct. Correct. So Lisp profiles policies are being executed.
So you worked on SDN.
Yeah, SDN, like I worked on this NSX, VT, and ACI.
Mm-hmm. Okay. They predominantly they use what is that? PGP. I don't remember that name for it. What's the multi-protocol PGP? It's layer 2 info for VXLAN tunnels.
VXLAN tunnels, correct.
Hmm.
L2 VPN, like
L2 VPN. L2 VPN. Yeah, exactly. BGP L2 VPN. That's
this is
amazing.
L2 VPN is having lot of things like VPWS, VPLS. I mean, like in service provider network, you will see MPBGP with VXLAN, not
Hmm.
VXLAN, not VXLAN,
VPLS.
VPLS and VPWS.
I don't know
Pseudo
about
wire,
VPWS. Oh, pseudoware. Okay,
pseudo wire.
okay, okay,
Pseudo wires are still like it is being used.
okay.
So for all the 2G networks, like VPWS is being used for the
Oh.
yeah, for the for this and for broadband as well. They are using VPWS only.
Hmm.
For 3G, 4G, 5G, it is IP based, like it is based on the VRF
Hmm.
routing table.
Yeah. So do you guys know? I mean, you know very well about VRF, right?
Yeah,
Hmm. I think
VRF.
I mean, in the previous patches they asked about VRF. That's not covered here. I think most of them they are familiar with that, right? In Palo Alto, they call us virtual router.
Correct, correct.
And have you seen I mean, anybody here, have you seen an OSPF with a bigger topology where you guys are using special area types, like not so stubby areas, totally stubby area, those special area types?
Yeah.
Yes.
So in service for like it was back in 2015, 16, they were using, then they transitioned from OSPF to ISIS.
Oh,
During that time, like they were filtering with this area type only, like with the LSA type
hmm.
only, they were filtering.
Maybe, yeah, for them, yeah, it
But
works. So,
during that time, like the topology that router were very less. I think
hmm.
like it was around 1500 or 2000 maximum. And when that router got increased, like after
Yeah.
there was a drastic change after 2017. So
Hmm.
the inventory of the router got increased from 2000 to last, like when I was there, it was 16,000.
Mm-hmm.
Okay, so then there was a architect, a Cisco architect. It was very renowned architect. He designed that a service provider network for
Mm-hmm.
a company. Then so during that time, like they bring this ISIs.
Oh, okay. Yeah, that's actually very true. As you said, see, your routing table grows up. I mean, even we have 50 plus sites, but I don't think they don't care about this area types. When I talked to them, they said that's okay. I mean, it's not a big routing table for 50 sites. But as you said, if your routing table is too big, like you have 100 sites, and that matters. And it is just a default route which points to ABR is totally fine to go out, right? So all it should know is the ABR should know the routes, right? So
Correct.
not the connected devices. So in that case, yeah, definitely this area types helps to what is it, optimize the network, and it actually reduces the intensity of those devices, connected devices. So in that
And
case, definitely it helps.
even with BGP as well, we usually
Mm, yeah, we use
actually
prefix. We use prefix list, and
we
usually
only
when you
see service provider network is like there are topologies like ring topologies,
mm-hmm.
access layer, aggregation layer, then NP we call network provider edge. I think
Yeah,
Sujit
yeah,
has
Surjit, what
covered.
is that? You have any questions, Surjit?
Hi Praveen.
Yeah, Surjit.
So actually I wanted to know what are the topics after BGP like OSPF, EGP,
Do you have this course content with you after
course
OS?
contents.
You didn't get it.
No, I didn't get.
So we have firewalls, then we have NAT,
Firewall, net,
VPN, IPsec, then finally you got SSL.
SSL. Yeah, these are like very important topics for me because I'm working in security domain, so IPsec and SSL, TLS.
Yeah.
These are so that's why I'm
This is the
putting
only
myself
topic
on
we
the
have in routing and switching.
yeah routing and switching. Actually, I'm not very much familiar. That's why I'm keeping myself on mute during these topics.
No problem. I mean, you can learn. I mean, it's an additional knowledge
Yeah.
if you learn routing and switching along with that. You have VPNs and everything.
Yes, yes.
It's good to know more,
Okay.
right?
Yeah. Thank you, Praveen.
That
Yeah,
is
no.
for all Surjit actually. Like security
This is,
people, they don't know routing, and routing people, they don't know security.
Yeah,
no,
see, yeah, that's true.
that is, correlated and I understand. But since, if you're not working since a long time in OSPF and this routing stuff, then it is really difficult to, to get again in these topics. So
Yeah,
yeah,
I
this is
totally agree.
additional. Yeah, this is additional help, but still
So
following
sometimes when
sessions.
you struggle with your security, if but if you know routing and switching better,
Hmm.
that's routing and switching is very, I will not say simple. As you said, you have to work on to do troubleshooting. You don't want to know I mean, you don't want to go to the very greater level, but at least a decent level of understanding will definitely
Yes,
help you,
yes,
right?
absolutely.
Yeah. Even my understanding to security is very decent level. I am not an expert in security, but I know how it works, what is zones, how to apply
Hmm.
policies to that level. But I don't know too deep about what they do this what is that IPS IDS rules.
UTM, you are saying like UTM.
Yeah, they do something
Yeah,
like
security
wildfire,
defense
exactly
breaches.
Hmm.
how it detects something. That's something I'm curious of learning that. But I have if they give a firewall, I can manage, but I can't say myself as an expert in that. I can find problems if it is causing some problem with routing, NAT, those stuff, VPNs, I know. But especially there is a specific team who manages this threat defense, right? I don't know that. Like DLP.
Yes,
Hmm.
yes.
Yeah.
DLP, lot of products are available now.
Yeah,
Uh,
DLP, SASE, they come up with
There,
SASE,
so
they
there
do
are,
that.
I mean, DAM as well, database activity monitoring.
Oh, is it?
FIM
Yeah.
is also
Then also encryption devices are also there. Encryption.
Okay.
So lot of things are there in security as well.
Yeah, correct.
So Sujit, you're working on network security, right? Or information security?
uh, working in network security, like working on IPsec VPNs, firewalls, Palo Alto, FortiGate,
Okay,
and
then it is
cloud
required.
security. Yeah. But I am
Uh,
also having good knowledge in InfoSec,
Information.
DSC domain as well.
Good.